All right. Welcome to a episode of Express Minitab Fun Times and Statistics. The Word document and Minitab data for this appears right above this video and above the video above it. So go up, you'll see it, it's files. Um, so we're going to start off today by doing some confidence intervals in Minitab Express. So I'm going to show you the two different, well, actually I'm going to show you more than two different ways you can do this. So the first thing I want to show you is where you can find confidence intervals in Minitab, and in Express, and there's actually two ways to do it. So I'm going to click on Express to activate it. The first way you can do it is all of the stuff we're going to need for chapters 9, 10, 11 are found in one sample. Ta-da! And if you don't have a one sample button or you forget that, you can also go to Statistics, One Sample Inference, and they're all in there as well. So in particular, today we're going to be looking at some examples. I'm going to show you two different types. One where I've been given summarized information and one where I have data. So this data down here I'm not going to be using right away. I'm going to be using that in number 2. So just ignore it for a bit. Alrighty, so here we go. I made my husband do this. It's kind of fun because I don't have time to sit around and eat candies and count things. So just pretend you open a bag of Reese's Pieces and you count how many of those Reese's Pieces are orange. And you find that 109 of them out of 200 are orange. So in case you didn't know, candy companies do different percentages for different candies. Orange in M&Ms. Wait, there is no orange in M&Ms. I'm thinking of yellow. Yellow is 15%, I do believe, so it's not like real consistent because there's 5 colors, and some colors are more prevalent than others. Brown is actually the most common in M&Ms, which I don't even know if you care. Anyway, so what we're going to do is we're going to use this sample information to calculate a 95% confidence interval. So here we go. I'm going to do it using the one sample option first. So click on one sample, go down to proportion. I know this is a proportion because I have counts, which means I had to have had categorical data, which means I have to be using proportions. So in this in particular, it asks you, hey, where's your data? Well, in my case, I don't have data, I have summarized information. So when I change this drop down to say summarize data, and notice what you're asked changes. It asks you for the number of events, 109. Ooh, my keyboard's a little stiff. Over 200, be careful with that. So as you look at this, think about how you form a proportion. You always do count of number of things I'm interested in out of the total. Think back to when we did probability. And notice that if this was a fraction, it's how it would look too. Like there's numerator, there's denominator, they're on top of each other. It's how I remember who goes where. I don't know if that'll help you. Hopefully it will. And then we're going to click over to options. Woohoo! So the first thing you want to do on here is you want to change the method. We are using the normal approximation method. If you're going to use this for your homework, make sure you change it to normal approximation method. That's what we won't. And then for confidence level, it's already on the one that I want. And real quickly here, I'm going to show you something just in case you are looking at this and thinking, oh, I can only do 90, 95, and 99. You can click in here and type something else. It will let you. So I can do something like 98 if I want to. It's just a little trick. But they give you the common ones to choose from since you're most likely to pick one of those. Alrighty. And then last but not least, this will become important later, is that this has to be a not equal to. So if you're wondering when on earth would I use some of these other options, stay tuned for video number 2 when we talk about hypothesis testing, because that's where you'll use that. Yay, I sound like a radio announcer. Alright, this is set the way I want it, 95, not equal to, and normal approximation, NNN. Let's do some proportions. That was an M sound, not an N sound. Okay. Let's hit OK before this gets more awkward. Alrighty, so it's going to give you a lot of information. I always double check this part first, 109 and 200, to make sure it's correct and matches my question, since that's a place where you could easily make a typo. Next up is your sample P. This is also known as P hat. That's just taking 109 and dividing by 200. That's the proportion you would get. And then here is our confidence interval. So one thing I don't like about Express is I can't just copy the confidence interval over. So I'm actually going to type it, because the rest of this is not my answer. And I really only want the stuff that is my answer. So 0.47598. That's probably more decimal places than I'm going to need, but hey, always better to be more accurate when you're not sure how much you want. It's always better to have more than what you need than less than what you need. For some of you who have had rounding issues on the tests and stuff. Oh yeah. Anyway. So there's my confidence interval. And so as you keep in mind as you look at this, keep in mind what it's telling you is you're 95% confident that when I look at all Reese's Pieces candies, not just my sample, the proportion that's orange is somewhere between 47.5% to 61.4%. So we can use that actually to answer the next question. Hey, does orange represent about 50% of all candies in Reese's Pieces? And you look back at your interval and you realize 50% is in the interval. So it is possible that the proportion of Reese's Pieces which are orange is 50%. So we can say yes. Since, let's see, I'm going to write it as as a proportion, not a percentage, because my intervals is a proportion, not a percentage. Since 0.05 is in the interval, it is possibly the proportion of Reese's Pieces which are orange. Woo. Now remember, there is a 5% chance that that's not the case, because it could be that it's much higher or much lower in the wings of, not within the 95%. Oh my, it's early. Okay, so what else did I want to say about this? Well, really nothing, because we've answered the question. Keep in mind, this is how you should answer questions. Just because it's a yes or no question doesn't mean you shouldn't explain yourself, because clearly I've indicated, why am I getting into that? Anyway, moving on. Scrolling on up, Alrighty, number 2. I'm going to pause and throw some enters in here, because this is very closely, yeah. Sorry about that. I also just realized that I didn't have a calculator installed on this Mac, so I had to go download one real quick. Oh, for something I'm going to do later. Sorry about that. So, for this next one, we're going to look at a sample. Well, actually, not a sample. You've got a bunch of donors, for the American Association of Retired People, and you don't know how this data was collected, so it might not be random. And one of the requirements that you have for good sampling is that it be representative, and the best chance you have at that is having randomness in the sampling method. So since we don't know, we're going to end up collecting a random sample ourselves. It's going to be a pretty large one, so hopefully that will fix any problems that it has. But what we're trying to do is we're trying to decide if over 50% of the current donors are 60 or older. So what I'm going to do with this is I have ages. This is quantitative data, and it's not going to help me because I need to know something about this proportion. So what I'm going to make Minitab do is I'm going to create a sample first of all, so that I have randomness inside my sample, and it's a good sample because of that. And then I'm going to code it so that I know who's over 60 and who's not, so I don't have to go through and count through the 300 customers who is and who isn't, because that seems insane. And then I'm going to use that code to perform a hypothesis test. Now, if you already have something like that only has 2 options, you do not have to code, because, well, you can define one of those to be your success and one of those to be your failure, and I'll talk a little bit more about that when I get into doing the confidence interval part. So let's start out by creating our samples. The first thing I need to select a random sample of, why did I do that? 300 customers from this file. So to get a sample in Minitab Express, you have to go up to the top and go to, I have to have Express active first. I have to go up to data, and what I want to do is I want to sample from columns, because I'm sampling from the data I already have. So I'm going to throw age in there, because that's what I'm sampling from. And I want to sample 300 columns, and I'm doing this without replacement, which means that there's no chance I'm going to grab the same individual more than once. The reason why you're going to want that is because if you have replacement active, that means that you could end up with the same person more than once. That would mean your sample is not independent, and one of the requirements to have a good sample is it needs to be independent. Alright, and that's all I need to do this, and what it's going to do is it's going to throw it in C2 or somewhere in here where there's nothing already there, which is good. Woohoo! Sample from age. So I'm going to actually change the name of this so I know how big it is. Sample age 300. This is just a habit of mine, so I know my different sizes to my samples in case I'm drawing lots of them and trying some different sizes to see what happens. Alrighty, so now that I've got my sample, And if you do this and you're following along with me, you will get a different sample from me. So yours might look different than mine. So there's that. Um, and now I'm going to recode this column into something that I can actually do a hypothesis test on. So to do coding, we're going to go up to Data, Recode, and we're going to do it to text because I'm changing it to yeses and nos. So let me throw sample age 30 in there, and I want to recode ranges. So pay attention that it brings up like how small my values are and how big my values are, my current minimum and current maximum in that data. Yours might be different if you're following along, so be careful. It's gonna look a little strange how we do this. So for my lower end, I'm going to create something where people are below 60 years old, and that's going to be my no's, the people that I'm not interested in, because I want to know, are they 60 or older? So what I just need to include here is something that will cover my minimum range, so something lower than my minimum. And then I want this to go up to 59, because these are the people that will be under 60, and I'm going to call that no. If you're doing this and you have more than one grouping that's going to have the label no, you got to make sure all your no's look the same. So since I capitalize my N, any no's that occurred after it would have to also have a capital. And then for my upper, I want anybody who's 60 or older. So since my high end is 96, I just need something bigger than that. So I'm just going to pick 98. Normally I just throw 100 in there because it's easy to type, but I don't know what I'm doing today. Those are going to be my yeses because that's the stuff I'm interested in. So yes, they are over 60, or no, they are not over 60. And then we're good to go. Woohoo. My big suggestion for this, that did not sound like a word, is that you never click this box, store a recorded column in the original columns. That'll overwrite the column you currently have. You don't want to do that unless you never are going to use the original again, which that's almost never going to happen. Let's hit OK. All right, there's our recoded sample. So now I've got some yeses and nos. And if you look down this, you can see and check for yourself, just visually real quick, that it is working. Like 69, that's 68. I need to wear my glasses more. That's a yes. 52 is a no. 58 is a no. Okay, this looks like it's working. Good. I mean, I trust you, Minitabs, but only so much. Anyway. So here's my recoded sample. So notice I have two options, something I can make a proportion of. How many yeses out of the total is something you can make a proportion of. You're counting one characteristic, one thing as your success. So this should work. All right, we are ready to go with creating a 95% confidence interval. So I'm now on step 3. Here we go. So I'm going to create a confidence interval for fun. I'm going to, rather than using one sample, I'm going to go up to statistics, one sample inference, and then down to the proportion, just so you can see it does bring up the same test. There you go. Now, previously I had used summarize data from this drop-down menu because I had a summary. Here I actually have raw data, so I want sample data in column. I got to tell it where my sample is. I want to use the recoded column because I want categorical variables. Yeah. So notice here it gives you the option of, oh, which event are you interested in? Yes or no? I am interested in yes, which is why I coded it as yes. So it'd be like, oh yeah, I want the positive thing. That's the thing I'm keeping track of. It's a thing. Whatever. Yes. Yep. So the other thing is, like, if you have like 4 or 5 options in here, like say maybe you're looking at something that had like freshman, sophomore, junior, senior, you can go in here and just select sophomore if you want to know how many sophomores there were. I think I have an example like that later. Anyway, as long as it's categorical, you can do that with a 1 proportion test. Alrighty, let's check our options because you're young and you always should. All right, we're at not equal to 95. That's what we want. Got to change myself to normal approximation. See, that was better that time. Alrighty. I'm awkward. Woohoo! All right, there is my interval. It's not looking too good here. Let's make this a little bigger. So 0.45. Boy, that's a lot of zeros. 92. 0.56. 3. 2, 4. 1. Did I miss one? I feel like I have not enough places there. Visual check, visual check. Looking good. Alrighty. Here we go. So the next thing you'd ask is, what's your margin of error for your estimate? So if you remember anything about margin of error is your your standard deviation of your sampling distribution times your level of confidence, or sorry, your z-score for your level of confidence, your critical value. So you'd have to go in, get the critical value, go ahead and, find your standard deviation from the sample proportion and calculate. I'm not going to do that. Minitab does not give it to you, but it does give you a way to do it. So if you remember how we calculate confidence intervals, we start with the sample estimate, the p hat, and we add the margin of error to get the upper end of the interval. So think back to your notes about when we were doing this by hand. And then we subtract the margin of error to get the lower end of the interval. So if you're looking at the interval parts, this part is the p hat minus the margin of error. This is p hat plus the margin of error. So this has two components to it, the original p hat, sample p, and the margin of error in it added together. So if I just needed margin of error, all I really need to do is get rid of the p hat or the sample p. So I can take the upper end of the CI and subtract the sample p to get margin of error, which is the easy way to do it off of Minitab, which is also why I needed a calculator. So the margin of error, we're going to do this as the upper half of the CI minus the sample p. And I'm writing out what this is in words, so when you look back at this, hopefully, if you're fast forwarding through the video, you know where the parts are coming from. So this is going to be that 0.56341. I wanted to put 321 for some reason. Oh yeah, that makes sense why I would want to do that. Minus the 0.506667. Ooh. Don't listen to your elders. The math is not the devil. I don't know what I'm saying anymore. Let's bring up my easy free calculator. Woohoo! Sorry. Alright, I've never used this before. Hopefully this won't go terribly. Oh, I hate the sound on it. Good thing I turned off sound recording for you guys. You probably wouldn't like it either. I do not endorse this calculator based on sound. This is me stalling. Ooh, so there's my margin of error. It is slightly bigger than 5%. Usually with margins of error, we try to keep them right around 5%, or lower. 3 to 5 is acceptable for most polls that people will use to estimate things. I don't know what it depends on what the poll is trying to do. So why do we keep margin of error small? Because if your margin of error is large, well, sometimes your interval is not very useful. So I actually saw, hold on a second, I'm going to go grab an image to show you guys. So this is a little hard to see. This is from a friend of mine who works for the National Weather Service. And this is one of the images they were releasing about one of the tropical storms that's like hanging out in the Atlantic right now. And I just had a good giggle at it because this is a terrible confidence interval. When they're creating the estimates for where hurricanes go, they determine path by directional things that we're going to ignore because it's not a part of our class. But to determine the radius of the storm, one of the things they're using is confidence intervals for how big they think it might get. So I love this one because it's like, it's a horrible estimate. My margin of error is too big here because it's like, where could it hit? Like, literally anywhere. Look at this. I think Maine is safe. Maybe. It's kind of hard to tell from this image. And California is clearly safe, but they have no idea where this storm is going. I shouldn't laugh about this because somebody might get hurt. But it's just an example of, they're looking at possible paths, and at this moment, it's just too unpredictable. Or their margin of error is just so large that they can't really say where it's going. So that's one of the reasons why we want to, avoid large margins of errors. It's a thing. God, I hope this is recording. Sorry. When she sent me that picture, she's like, ah, you can use this in your class. It's fun. Anyway, so there's our margin of error. Like I said, a little bigger than 5%. I mean, it's just a little bit bigger. It's not horrible, but I would prefer it to be smaller always because I would prefer some accuracy. Let's write ourselves an interpretation of this interval. So interpretations have only 3 pieces. The first part is you must describe how confident you are. So let me get rid of the extra enter I have in here so this will fit on one page. We are 95% confident that the proportion of, who teaches this class? So be careful when we're writing in formal ways. Clearly I'm not an English teacher. We should use third person, so we're always using we are, not I am. It's just good advice. Because you also didn't collect this data, so, you want to include some other people in there, and you'll probably have to cite them later. What are we estimating here? Oh, the proportion of donors that are over. Sorry. The proportion of. I forgot where this data came from, so I'm reading back through. Da 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 da. Current donors. Oh, they're going to advertise a magazine if it's over 50%. Okay. Oh, so these are people who read AARP. I read this wrong the first time. I was going to say, oh, percentage of people in AARP. Whatever. Anyway, so we're 95% confident that the proportion of AARP magazine readers whom, ooh, that sounds so formal. Oh well, are over 60 is between, where's my interval? I'm going to do 45.00% and 0.01%. Bad rounding, teacher. Naughty, naughty. And 56.32%. There was where we're at. So these are actually the three things pretty well that you need when you're interpreting an interval. So remember, this is how we interpret and use it, which is not the same as what it is. How confident we are, bam. And then what our proportion is about, the context of what our estimate is, and the readers that are over 60. And then what the interval actually is, it's this much. So my proportion is between 45% and 56%. Be careful with this. Usually we do use the percentages here just because intervals and interpretations are designed for the general reader to possibly understand, depending on who your general reader is. And in general, I'm saying general too much. We want others to read this and understand, and for some reason in communication, people tend to, instead of, saying proportions, they use percentages. I don't know why this is true. If I could go back in time and change that, I would, because I think it would be something that would fix a big source of confusion in our class. Not to use the weather as an example again, but you don't say, oh, there's a 0.3 chance of rain tomorrow. You say there's a 30% chance of rain. That's the difference I'm talking about here. For some reason, in common vernacular, we use percentages. I don't know why. I think it's dumb. Yep. Cool. Based on what I'm seeing, should they advertise? My thoughts are, it's possible that over 50% are, because we wanted that, right? Where is it? Yeah, if it's over 50%, then we should donate. But looking at this interval, it's a big fat maybe, because 50% is in there, but it's also possible it could be lower. It's also possible it could be higher. Now, be careful. A lot of students will look at this and be like, oh, 50. There's, it goes up to 56%. So there's, more percentages that are there that are higher than 50, and there are fewer that are less, because you're like, oh, well, down to 54, that's only a 5% range, up to 56, that's a 6% range. It's more likely to be that. Absolutely not. You have no idea where in that range your proportion actually falls. It could be any of them, and they're all equally likely. Don't look at this and say because there are more that are higher, that it's more likely to be higher. You don't know that. All you know is it's some value possibly in there, and you're only 95% confident that that's the truth. So it could be that it's actually much lower or much higher. You don't know from this. So confidence intervals are a little, disappointing for this reason. They do give you an estimate, but the estimate might not always answer your question. So my answer is going to be maybe. Though 50% is in the interval, it is impossible to say, that it will be over 50%, since the interval also contains values below 50%, which are also possible. That's a really long-winded one. Oh well. So it might be that it's higher, might be that it's lower. You can't really say. So you can't definitively say yes, so I would say no in this case. Now, if I would have done this confidence interval with my sample and gotten something that was like, say, the lower end was like 52 and the higher end was 58, then yeah, because I know it's always going to be above 50. Or if I had got something that was consistently smaller, so went from like 40% to 45%, I'd be like, oh no, it's pretty much lower than that. We should not do the advertising. At this point, it's kind of like a judgment call. You should decide for yourself, because it's a maybe. It's not a definitive yes or no, unfortunately. So that's where we're at with this. The reason C is on here is because C is actually something you could answer using a hypothesis test, not a confidence interval. So stay tuned for that. That's all I got.